Today we're going to look at the standard deviation, which is one of the important concepts in statistics. Actually, it's one of the measures of dispersion. Dispersion has to do with how much all the data are spread out. So one of the other measures of dispersion would be the interquartile range, or the range of the values, but actually the standard deviation is probably the most widely used. So I'll first write down the formula for it. So the standard deviation is many times denoted as small sigma, and then it's the root of taking the sum xi minus mu squared over n. Well, this looks a little bit complicated, maybe intimidating, but we'll step by step try to unravel the formula and then make clear what this is all about. Let's first look at a few notation issues. The mu is many times referring to the mean, at least in statistics. Of course, you know the sigma, it has to do with adding up. And then n is the total number of data we're talking about. And then we take the root. And by the way, we can already mention that the variance is exactly the same, but then without the root. So, by definition, the variance is the square of sigma. So, once you know the sigma, it's easy to find the variance. To illustrate this formula, I would like to look at two situations. So, we talk about a class that, two classes, they both made the test. And I'll just write down the test scores for class A for a moment. So these are the test scores, and the maximum is 7, like it's in the IB system. So the first class, the scores are 1, and then 3 2s, 3 4, 5, 3 6s, and 7. And class B, the scores are 2, 3, 3, and then 5 4s, 2 5s, and 6. So if I didn't make a mistake, both classes have 11 students, and we would like to compare the two classes. So one way to compare them is, of course, to look at the mean of the two classes. Well, if you just look at the data, you may get an idea what's going on here. As you can try to find the mean of A, you can just add them all up and divide by 11. I think the total is 11. You can do the same for B, and it turns out they both have mean 4. Of course, another way to look at it is considering there is some symmetry there. Like you have the 4 and then the 3 and the 5, they cancel out, you could say, they're both, and then the 3 2s and the 3 6s, the 1 and the 7. So because of the symmetry, it's quite easy to see that both have a mean 4, so you can write out like the mu A is 4, and also the mu B is 4. So with that respect, they are equal, but if you just look at them again, you can say, well, there are some differences. And it has to do with the way the grades are spread out. In this situation, you have some very low grade, a 1 and a 7. You have a lot of 2s, a lot of 6s. Whereas in the second class, all grades are relatively close to the mean, close to the 4. And it will become even more clear if you draw a histogram, but I think you can even see it from the table. So how can we measure this? How can we measure how much they are spread out? So the first thing is that you can, for every grade, look how far the grade is from the mean. So we just make another column there, and we write down the xi minus the mu there. Yeah, so you can say the grades, you can call there the x's, and here as well. So this is class B. And so the first column, we just look how far they are from the mean. Well, since the mean is 4, 1 minus 4, this is minus 3, minus 2, minus 2, minus 2, minus 1, 0, 1, 2, 2, 2, 3. That, I think we can do that. So more or less we are trying to find how far the values are from the mean, and then like the average distance of the mean. That's something what we'd like to find. However, you can easily see if you take the average of these numbers, it turns out to be 0, because some are negative. So that's why we need to make a small adjustment. So one way would be maybe take the absolute value and then take the average of that, but for some reason, which we will not discuss now, it is chosen to take the square of this distance. Sometimes this is called, by the way, the deviation, how far it's from the mean. So we take the square of the deviation and then we take the average of that one. And I think you start to recognize a little bit what's going in this formula. We take the xi minus mu squared, we add them all up, and we divide them by the total. So that's actually what we do in this table as well. So our next column will involve xi minus mu squared. So we just take these numbers and we square them. That's 9, 4, 4, 4, 1, 0, 1, 4, 4, 4, 9. And notice if you square a negative number, it becomes positive. So now we can try to find the average of the deviation squared. That means adding up all the numbers in the column. Well, that's 9 plus 12, 21, 22, plus 22, 44 is the sum. That means for class A, we end up with an average of 44 divided by 11, which is 4, and then the square root will be 2. Okay, so for class A, we can write down the sigma to be the root of 44 divided by 11, which is root 4, which is 2. Okay, now let's look what happens if we apply the same to the second class. We would expect a smaller value of the standard deviation because the values are close together, and that will be confirmed if we do the calculation. So also here we write down the column xi minus mu, and then the next one xi minus mu squared. So let's see what's happening. The mean is still 4, so we have minus 2 there, minus 1, 0, 0, 0, 0, 0, 1, 1, 2. So the squares are 4, 1, 1, 0, 0, 0, 0, 0, 1, 1, 4. Adding up, you can easily see it's 12. Yes? So this is the deviation squared. They add up to 12, so the average of the deviation squared will be 12 over 11. So we can say for class B, the standard deviation is root 12 over 11. And using a calculator, that turns out to be 1.044. Of three significant figures, 1.04. So you can see the value is definitely smaller, because the values are more close together. Okay, just a few remarks here. If you focus on class A, it's also possible to write down the table using frequencies. And I'd just like to see what happens then. And that also means a small adjustment in the formula. So if you write down the same table using frequencies for class A, you can say, well, these are the grades. 1, 2, 3, 4, 5, 6, 7. And then we have the frequency involved. So it's how often it occurs. So for grade 1 it's 1. For grade 2 it's 3, and then we have a 1, a 1, a 1, 3, and a 1 again. And then you can do the same kind of calculations. I don't think I have to go into all the details. So you can again write down the xi minus mu and the xi minus mu squared. But then of course you have to multiply with the frequency. Yes, and that will give you like a weighted average. I think you can probably see how that works yourself. Another important remark I should make is that, of course, your calculator can also deal with this. For example, if you include the frequencies, you can enter these columns as lists in your calculator. So most calculators, they have the stat menu, stat edit, so you can enter the list there, and then if you move to the stat calculate menu and you choose one for stats, it will give you all kind of information about the situation. It will give you the mean, it will give you the standard deviation, etc. So I would say certainly try that on your calculator. And so I'll quickly summarize the functions that are involved. So in the calculator you first go to the stat edit menu, and there you can fill in list 1 and then list 2 if you have the frequencies involved, and then you move to the stat calculate menu, and that will give you the values like the mean, standard deviation, etc. Yes? So I definitely say you should try that and see how this works on your calculator.